Mapping devices handle parameter modulations across multiple inputs and outputs. The Hydra has a single input which can be altered in different ways for each of its multiple outputs. The metamixer and formula devices have multiple inputs and combine them in various potentially complex ways to craft a single output. The Hydra's input is plainly labelled, while the metamixers are input A, B and C. However, in the formula, they're only referred to as A, B and C, an important distinction that we'll look into later. As with most effect parameters, the input values of these three devices can be changed through a variety of methods. The user can perform the changes live, or the value can be automated via effect commands, graphical automation, or by another effect device. It's this last option of cross-routing multiple effects that makes the mapping devices so powerful. The Hydra's outputs are labelled as such, under and to the side of the input, while the metamixer and formula's output is the first parameter, dest. Each features a set of 3 boxes, where you set the destination track or sampler effects chain, the chosen effect, and the parameter. The Hydra device allows the mapping of its input value toward up to 9 different destinations. Min and max set the minimum and maximum values to be used from the range of the destination parameter. By default, the range is 0 to 100%, but this will change to match the parameter type. Note that it's possible to reverse the output mapping by making the min greater than the max. The scaling option changes how the output value will be mapped across its range. Normally this is applied in a linear fashion, but you can also select from 2 exponential and 2 logarithmic scales. The metamixer accepts input from up to 3 sources and combines them to create a new output value, as represented by the meter to the right. Controlling how the inputs are combined is done with the weight parameters, which adjust how much influence an input has over the final output value. Each input's weight, relative to the others, is represented by the graph at the right. This device also features min, max and scaling options, and they function in the same way as in the Hydra device. Like the metamixer, the formula device accepts input from up to 3 sources and combines them to create a new output value. But as you can tell just by looking at it, this is the most complicated effect in Renoise and Redux, because that output value is generated by coding what you want the device to do. This is done in the two sections at the right. The upper code box doesn't have to be used and is only needed when programming more complex functions that will be called by the formula below. The language used is Lua, and pressing the help button brings up the provided variables and math functions. We're obviously not going to start teaching mathematics or coding here, so if you're interested in learning more, then I'm sure you already know what to do. We are, however, going to look at the variables specific to Renoise and Redux. A, B, and C are the three inputs, and although they can be renamed, they must be referred to as capital A, B, and C when used as variables in your code. The other variables and constants must be written with capitals as well, while the math functions must be lowercase. If your code or formula contains an error, then the status above the code box will show this. And clicking on the icon will bring up the full error message. Output is the value that was generated by the previous run of the formula and, like the inputs, ranges from 0 to 1. This allows you to carry the previous output forward and build upon it each time the formula is calculated. Two things can trigger a new calculation. The first of which is if an input is used in the code or formula and its value is changed. Second, the calculation also happens every tick. If you're unfamiliar with the concept of ticks, it's simply that, just as a pattern or phrase is split into a number of lines, so each line is split into a number of ticks. The ticks per line value, TPL, can be adjusted in the song options panel, or automated with the effect command ZKXX, or with graphical automation in the master track. The code in the code box is only executed once during startup or when a change is made. Any functions or global variables created here will be available to the formula. And by the way, you can hide both of them by clicking the button here. Playing is simply whether the song is playing or not, returning a 1 or a 0. S-rate is the sample rate of the application, set in Renoise with the Audio tab of the Preferences menu. As you can see from the default formula, you'll need to make use of this to code something time-based. For something beat-based, you might make use of BPM and LPB, which are the song's beats per minute and lines per beat values. And perhaps also TPL, which we looked at earlier. Samples per line can be a little confusing if you're not familiar with the terminology. While the term sample is commonly used for stored waveforms, It also refers to the smallest unit of audio playback. SPL is related to the S rate, which sets how many audio samples are played back per second, while the SPL is how many are played over the course of a line in the pattern or phrase editor. Num lines is exactly what it says in the description. As are tick and line. Line F is the same as line, but with the tick divided by TPL calculation added to it, saving you from having to do that yourself. The next two sections are easy to understand, since they're based on terms that you're now already familiar with. The first section is used for tracking song playback. While in the second are a set of counters that run constantly even while the song is stopped.